Okay, good morning everyone. Today we want to learn about standard form. What is standard form? So before we proceed to this topic, can all of you determine the blocks? Yes, I sure that all of you have learned this block. Yes, it related with the base 10. So let us determine it together. So as the first picture, we call it as unit where it represents ones and it written as 10 to the power of 0 in the base 10. The second picture is rod, where 10 units make one rod, which it represents tens, and it will be written as 10 to the power of 1 in our base 10. The third picture is flat, where 10 rods make one flat, which it represents hundreds. So in the base 10, it will be written as 10 to the power of 2. The fourth picture is a cube, where 10 flats make one cube, where it represents thousands, and in the base 10 it will be written as 10 to the power of 3. And the fifth picture is rod of cubes. We call it as rod of cubes, where 10 cubes make one rod of cubes, where it represents 10,000, and it will be written as 10 to the power of 4 in our base 10. And for the last picture is flat of cubes, where 10 rods of cube make one flat of cube, which it represents hundred thousands, where it will be written as 10 to the power of 5. So for these examples, all of the base 10 blocks will have its own place value, where the unit is 1, right? This is tens, and this is hundreds, thousands, 10,000s, and 100,000. So the amount of all these blocks are 352,648. As for the next example, it is the same right as before, where the base 10 blocks will represent, each of it will represent the place value, right? So the amount of these blocks are 214,645, whereas the hundreds thousand here have two flats. The rods of cubes here is represent 10,000 because it consists of 10 cubes here, and you can see it and determine it. Okay, without wasting our time, let us explore more about base 10 and what is the base 10 actually for and why it's related with the standard form. So, what is base 10? As for this, it said that base 10 refers to the numbering system in common use around the world that uses decimal numbers. Base 10 is also the basis of place value number system and also called the decimal system or ternary system, where the base 10 actually will be written as decimal number. So for these examples, which it will be written as decimal number, where for the left side here it is a whole number and the right side here, it is a decimal fraction, which is the 3 will be written as 3/10, which in the base 10 it will be present of 10 the power of -1, right? Whereas each place is 10 times larger than the place to its right. So, as for the place value, numbers that are bigger than 1 and are on the left side of the decimal point will fit into the following place values, where for the first is it represents the ones, then tens, hundreds, thousands, 10,000, and 100,000. They are to the right of the decimal point. The place value appears differently, where the first place value after the point is tenths, where it will be written as 10 the power of -1, and it will be 10.0, pardon me, 0.1. And for hundreds, it will be written as 10 the power of -2, where it represents 0.01, whereas the 1 is in the place value of hundreds, As for thousands, it will be written as 10 the power of -3, where we write it in the decimal, it will be as 0.001, and for the 10,000s, it will be written as 10 the power of -4 in the base 10, where it will be written as 0.0001, whereas the 1 is in the 10,000th place value, right? So for the 100,000, where it will be written as 10 the power of -5, and in decimal numbers it will be written as 0.00001. So we will proceed to the next slide, which we will learn more deeply about standard form for our today's lesson. Yes, our today's lessons, right? So what is standard form? It is difficult to read numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 0, 0, or 0.000234567. To make it easy to read very large and small numbers, we write them in standard form. Any numbers that can be write as decimal numbers between 1.0 and 10.0 multiplied by a power of 10, which that I have mentioned just now on the previous slide. It had related with the base 10, right? So here it is said to be in standard form. So here it is. There are two examples of standard form, which is 1.98 times 10 the power of 13 and 0.76 times 10 the power of 13. So class, would you open your textbook on page 37? So let us discover it together. How to change a single number to standard form? When a single number is changed to standard form, numbers with value more than 1 will be given positive index. Numbers with the value less than 1 will be given as negative index. So for this decimal number, it seems like it is less than one, right? So it will be an negative index. So let's see for the example here. So 0.3325 equals to 3.25 times 1 over 10, where 3.25 times 10 to the power of negative 1. Why negative 1? Because we want to convert this fraction into decimal numbers. So it goes same goes to this example, it is negative 3. So we will see for the example for the single numbers, convert the standard form into single number, where this is its standard form. We want to convert it to single number, which is 4.17 times 10 to the power of 5 equal to 4.17 times 100,000, and it will produce 470,000. For the negative index, it will be 8.063 times 1 over 100,000, and it will produce 0.000863. For this example, you can use a perfect measurement, metric measurement in standard form, where theta will represent of 10 to the power of 12, where this number we will multiply it by 10 to the power of 12, and it also we convert the single number to the standard form, which is 3.05 times 10 to the power of 3 in the bracket, and it will be times with 10 to the power of 12 in bytes. So 3.05 times 10, why we have to plus? Because it is multiply, whereas 3 plus 12, and it will produce 3.05 the power of 10, 3.05 multiplied by 10 the power of 15 bytes in the standard form. And for this example, it seems like less than 1, right? So it will be 0.057, and this is nano will represent of, so let's see at this, 1 times 10 to the power of negative 9. So let us see for this example, it will be 0.0057 times 10 power of negative 9 in meters. We won't convert it in standard form, but in meters. So 5.7 times 10 to the power of negative 3, where we convert this single decimal number to standard form and in bracket and multiply it by 10 to the power of negative 9, where 5.7 times 10 to the power of negative 3 plus with negative 9, it will produce 5.7 times 10 to the power of negative 12 in meters. So as for your exercise, I would like you to do this question that I have ticked just now. So just do for the tick question. Okay, class? So for the question 3, I will allow you to refer the metric measurement in standard form that I have made here. So you will refer it here. Okay, class? Class, are you done with your exercise? It should be done, right? So let us check the answer together. So for question number 1, which allow you to convert the single numbers to standard form, right? So you can use the bouncing method. So here 35 will equal to 3.5 times 10 to the power of 1. So for B, it seems like the equations where 5075 will equal to 5.075 times 10 to the power of 3. So for D, 97.25, where the dot or the point must be after 9, right? So we will draw the boundary arrow, one boundary arrow here. So the answer will be 9.725 times 10 to the power of 1. So for H, we could see it is less than 1, so the index would be negative in form of negative. So 0.0375, answer in standard form is 3.75 times 10 to the power of negative 2. So for number 2, for question 2a, it's allow you also to convert the standard form to single numbers, right? So 2.5 times 10 to the power of 0 would be 1. So the answer will be 2.5. So for B, 3.75 times 10 to the power of 1, it will be 37.5. So D, 5.707 times 10 to the power of 3 will represent 100, and the answer will be 507070. For F, 6.2 times 10 to the power of negative 1, 10, and the answer would be 0.62. As for the 8.504 times 10 to the power of negative 4, the answer will be 0.008504. 3a, the answer is 1.050 times 10 to the power of 6 meter. So for B, gigabytes, 216 gigabytes, and the answer will be 2.16 times 10 to the power of 11 bytes. For C, you may get 7.5 times 10 to the power of 11 liter,
Where D, you will get 8.9 times 10 the power of negative 17 meter.
So class, what have you learned today? Are you understand with the topic that is standard form? It is hard or easy for you? I hope that you understand this topic well, as it is not very hard to understand. So what have you learned for today is you will be able to convert single numbers in standard form, such as 2000, and when you convert it into standard form, it will be 2 times 10 to the power of 3. So next, you will be able to convert standard form in single number, such as 2 multiplied by 10 to the power of 3 will be 2000, which 10 to the power of 3 represent 1000. And then you will be able to convert the metric measurement to the given units in standard form. So for the third objective, you will be able to convert the metric measurement based on the provided table, and it is the same as you convert the single numbers in standard form. So before we dismiss our class, I would like to give you a homework. So class, please do your homework as you can understand it well. And if you already done with your homework, please send it back to me through WhatsApp. So I will give this homework, this handout in our WhatsApp group. So I hope you all can do it well as we have learned it just now. We will dismiss our class. Thank you.